This is the video for Unit 5, Lesson 3, Radical Equations. So our goal is going to be to solving a radical equation and identifying what's known as an extraneous solution if they exist. And we'll talk a little bit more about that in a moment. So the steps for solving are very similar to solving a linear equation, except instead of just isolating the variable, we first isolate our radical, and then we do the inverse to remove the radical, which can include squaring, cubing, whatever index we're working with. We're going to solve and then check for what's called an extraneous solution, which is a solution that occurs algebraically in the problem, but it doesn't necessarily satisfy the original equation. So when we're working with a radical, remember, we can't take the square root of a negative number. So what that means is if I have like the square root of x minus 2, underneath this radical, I know whatever's under here has to be greater than or equal to 0. I'm not allowed to take the square root of a negative 5 or a negative 10 or anything like that. So what that means is our original problem, all the x values have to be greater than or equal to 2. Otherwise, I'm going to get something that's going to not be a real solution to our problem. So just something to keep in mind when we talk about the domain. Our domain for this would be x such that it's greater than or equal to 2. Or maybe you would write it a different way. But we have to keep that in mind for radicals. There are certain values we're not allowed to have under that radical. So now when we go ahead and solve, I'm going to get my radical by itself. So I'm going to go ahead and subtract 3 from each side. We're going to get a 2. This is a little index of 2. It's a square root. And to do the inverse or undo that, I'm going to square both sides. And that's going to eliminate my radical. And I'm going to get an x minus 2 equals 4. I'm going to add. And I get an answer of 6. 6 is greater than 2, so it does satisfy my original equation. If I substituted it back in, I'd get an answer that makes sense. And so my answer to this would be x equals 6. I could also check it if I wanted to check to make sure it was correct. So if I did 6 minus 2 square root, did I get 2? And I actually would get 2. Checks out. For this next example, same thing. We have here, we're doing now a cube root. So a cube root, we actually can have a negative number. So if I do the cube root of negative 8, I could actually get negative 2, right? Because a negative times a negative times a negative is a negative. So this one, we still want to check it out, but it's not going to have as many things that kind of fall apart as the other one. So when I go ahead and solve this, I'm going to get whatever the radical is by itself. I'm going to add 1. I got the cube root of x equals 3. I'm going to do the inverse to both sides. I'm going to do the cubing to both sides. I get x to be 27. If I wanted to check my answer, if I do the cube root of 27 minus 1, does that equal 2? It actually does. So it checks out. That is a solution. For question number 2, this one's a little bit different. We have multiple variables, but same idea. I have my radical I isolated. It's a square root. To undo that, I'm going to square both sides. I get x squared equals x plus 6. I have an x squared and an x in the same problem. This is a quadratic. So I'm actually going to want to set it equal to 0, which we haven't seen that in a while. So if I have x squared minus x equals 6, I'm going to subtract. So x squared minus x minus 6 equals 0. And now I'm going to go ahead and factor this out. So factors of negative 1 that add to, or factors of negative 6 that add to negative 1. That's x minus 3, x plus 2. When I set each factor to 0, I'm going to get 3 and 2, negative 2. So these are my two solutions. And then I just have to check that both of them work. So the original problem, I'm going to see, does 3 equal the square root of 3 plus 6? It checks out. I'm going to check the same for negative 2. Does negative 2 equal the square root of negative 2 plus 6? It does not. So it would be negative 2 equals 2. So that means that negative 2 is actually an extraneous solution. So my only answer is actually x equals 3. And then finally, for the last example, I'm going to do the same thing. I'm going to isolate my radical. So we're going to go ahead and square both sides. So 3x minus 2, x minus 4 squared. I'm going to write it out twice and distribute. X squared minus 4x plus 16. X squared minus 8x plus 16. And then I have a 3x minus 2. We have x squared and x in the same problem, so we're going to get them all on the same side. And so we have x squared minus 11x plus 18. And now we're going to go ahead and solve it out. So we're going to factor. It'll be minus 9 minus 2. We'll get 9 and x equals 2. And now we're going to go ahead and check that it works in the original problem. So again, my original problem is the square root of 3 times 9 minus 2. And does that equal the same as 9 minus 4? And so on one side we get 5. On the other side we're going to get a 5. So that first solution checks out. And then the second one, try the same thing. 3 times 2 minus 2. And then it'd be 2 minus 4. And so we would end up getting that to be 2 equals negative 2. So the second one's actually not a solution that works. So our only solution is x equals 9. And that's it. So if you have any questions, feel free to ask in class, sign up for T-Bolt time, or go to the center.